Hello there. Welcome to the chemical bonding and structure presentation. My name is Lwazi Nkosindlovu. Okay, so to introduce it for today, so this is basically a presentation that will look at defining polar molecules and dipolar moments, or giving examples. It will look at to predict types of water, intermolecular forces, and finally give explanation on the consequences of multiple hydrogen bonding in water. Right. So by polar molecules, we are basically referring to molecules that have an uneven distribution of the charge across their geometry, ending with one side being positive and the other side being negative. Okay, so I've got an example of a water molecule there where oxygen shares electrons with two hydrogen atoms in a covalent bond. Dipole moments, well, a simple definition of dipole moments will be a measure of polarity of the molecule, right? So with dipole moments, the larger the difference of electronegativity, the larger the dipole moment will be. So dipole moments have a magnitude as well as a direction. Okay, so if that is to be illustrated in say a diagram, I would use the hydrogen chloride as an example. So we would have hydrogen and chlorine, then draw an arrow going from hydrogen towards chlorine, which will illustrate that a hydrogen atom is less electronegative than the chlorine atom. For a dipolar moment to happen, okay, there must be a polar bond for the dipolar moment to occur. Types of water intermolecular forces. So basically, we've got the dipole, which is basically the attractive forces among polar molecules. Then we've got the ion dipole, which arises between ions and polar molecules. And then we've got the ion-induced dipole, which is a non-polar molecule, which is when a non-polar molecule is polarized by an ion placed next to it. Okay, and dipole-induced dipole, which is basically non-polar molecules transformed into induced dipoles due to the presence of polar molecules nearby or just close to them. Finally, the consequences of the multiple hydrogen bonding in water. So basically, hydrogen bonding allows for ice to be less dense than liquid water. So which means the ice will float in water. Hydrogen bonding is in the heat. Hydrogen bonding in the heat of vaporization assists create perspiration, a conducive way for dropping temperature of animals. Right? So water harbors from extreme temperature hikes near big water bodies and wet environments. And globally, water helps regulate temperature, which is rather basic. And finally, to conclude, I would say that dipole moments are a consequence of polarization, and polarity allows for water molecules to attract each other. Thank you.